thank you so much for being here. We've had a number of discussions on this subject, and I think the knowledge range on this group is enormous. And I think I'm at the bottom of that poll. And as I said to my wife, I'm going to find out if we're going to have to drink our own pee here tonight. So and that's about where I began. And the rest, you got some questions from Sally, and Paul also responded to my request for questions to get to you in advance. As to what we're trying to do, I think that at some point, SEPA ought to provide some advice to the county government on this. And I think we're still in the information gathering phase of that to decide what kind of advice we ought to give. So in terms of the managed recharge and related issues as well, monitoring of the larger set of groundwater supplies that are available in Maryland, or particularly in this region. So I would say, tell us what we need to know.
Andy, okay. Let me interrupt for a second. If I do interrupt, it's for clarification. I will be taking notes. And if you'd be kind enough to share your slides with us, we'd appreciate it. And I noted that you'd like us to keep it within SEPA without further consultation before we distribute it further. And we agree to that. Thank you.
Yeah, no problem. And thank you all for inviting me. SEPA has been a really great ally for Maryland groundwater for many, many years, going back to the Woolman report. And we really do appreciate your advocacy. And I'm happy to try to tell you how we feel about MAR and about Anne Arundel County's pilot project as we understand it, and the state of Maryland groundwater in general. So anything's fair game. I do not have a slideshow prepared. I do have some graphics I could share, but perhaps since it's being recorded, that could serve as a reference for you. So I did get some questions in advance from Mike. And I guess I could just start with that. I mean, that might be a good point to start. I assume you're all familiar with the proposed MAR project in Anne Arundel County.
Yeah.
Sorry,
maybe
Mike,
a couple. I'm thinking maybe a couple of sentences, just to kind of we're all running at the same speed.
Sure. Okay. So there's been a proposal to, and this would be a first in Maryland. It would be a project where a wastewater is highly treated to drinking water standards, and then a injection well would inject the treated wastewater, the potable product, into a confined aquifer at depth in Crofton. And one big problem is that there's no regulatory framework to make this happen in Maryland. It's never been done. It's never been, the regulations haven't been written. This has happened in other states. It's been a necessity in other states, particularly the Southwest, where there's really a water crunch and a large water deficit for the populations that need the resource. Maryland being a fairly water-rich state, we've been blessed with a lot of groundwater resources, and at this point, it might be hard to argue that it's necessary from the point of view of groundwater depletion, because there is still, and especially in Anne Arundel County, there is still quite a bit of resource. It is slowly declining over the years, as everybody is probably aware. And I should say that the one analogous project that is probably closest to what's being proposed is down at Hampton Roads in Virginia. It's the exact same Cretaceous aquifer. It's called the Potomac Aquifer down there. Up here, we've divided into 3 different units: the Patuxent Aquifer on the bottom, the lower Patapsco, and then the upper Patapsco. That would comprise the Potomac Group aquifers in Maryland. Down in Hampton Roads, what they're injecting into at that location, the SWIFT, it's called the SWIFT facility. I don't know what exactly that, it stands for Sustainable Water for the Future or something. It's an acronym that's kind of cute. But at the location where they're injecting their treated wastewater, the Potomac aquifer is actually brackish. So it's already salty. There's been saltwater intrusion in this area, so that what they're doing is they're injecting into very high TDS, high chloride aquifer. They're injecting a plume of fresh water. That would be the main takeaway I would say when comparing the two situations. The situation in Anne Arundel County is very different. So the proposed aquifers that they're targeting for injection are actually very pristine fossil groundwater. So in other words, water in these aquifers hasn't seen the atmosphere for probably tens to 100,000 years from the late Pleistocene, probably. And so as a result, and being confined aquifers, these aquifers do not have any kind of human contamination. They're also not threatened at the Crofton location by saltwater intrusion. So that's a major difference. So really, they're not degraded, what we would call a degraded aquifer. The Potomac aquifer at Hampton Roads would be considered degraded because it's already too salty to drink. So it's what I would consider maybe a more acceptable location for this kind of practice. So in general, MAR, managed aquifer recharge, this type of injection is warranted under really three different scenarios. Under a very dire groundwater depletion scenario, like you might see in the desert Southwest or California. Under situations where there's saltwater intrusion and you want to increase the freshwater pressure to keep the saltwater at bay. And then the third scenario would be if you're seeing land subsidence due to excessive groundwater extraction. So when groundwater is used in excess, you can decrease the fluid pressure within the aquifer and actually see the land sink. This happens quite often in the Central Valley of California, parts of Arizona. Houston, Galveston is a big area. Mexico City is an incredibly scary example of this. In Maryland, we've been monitoring for land subsidence at well fields in Anne Arundel County since 1999. And really, it's fairly minimal. So I wouldn't say that that's a existing scenario that would warrant MAR. I mentioned before that saltwater intrusion is not an existing situation that would warrant MAR, and I don't believe groundwater depletion at this location is an example that there is a situation that would warrant MAR. So why do they want to do it in Anne Arundel County? And it's rather complicated, but the wastewater discharge to the bay is subject to taxes based on the TMDL load, as I'm sure you're aware. And this is actually a similar situation to Hampton Roads because they share the same Chesapeake Bay regulations. They've used this as a way to get around paying these fees for discharges of surface water into the bay by injecting the water into an aquifer. So, I feel that this is probably being driven for the wrong reason. It's putting a pristine aquifer at risk in order to, get around a surface water issue, TMDLs and nutrient loads to the bay. So that's kind of where personally I'm coming from. But as an agency, we have a mandate to protect the natural resource of groundwater and to preserve it for future generations of Marylanders. And anytime that you're treating wastewater and injecting it into a pristine freshwater aquifer, there's a danger that you're going to have a release or a breakthrough, as it's called, in the treatment chain. This has actually happened at Hampton Roads. Certain aspects of the treatment have broken down, and by the time they realize it, they've realized they've already injected many tens of thousands of gallons into the aquifer. In the case that I can recall hearing about, it was nitrate that was exceeded. And in that case, they had to start pulling the water back out. Now, if that were to happen in a very freshwater aquifer that the population of Anne Arundel County is relying on, and it's something other than nitrate, perhaps it's PFAS or some other emerging contaminant that we don't even know to test for yet, that's really kind of a scary proposition. And being that it perhaps isn't a warranted situation, then it seems like an unnecessary risk. That's where we're coming from. So if you have questions about anything I just said, I know I just kind of rambled for many minutes from many subjects, but some of it relates to some of the questions. Sally had asked about the difference between pristine and contaminated aquifers. Now, I wouldn't say. I mean, you could make an argument that the Hampton Roads Potomac aquifer is contaminated, but it's really a natural contamination. So we have many geogenic contaminants. They're natural. They come from the geology and the sediments within the aquifers. Arsenic is one that you may be familiar with that occurs in southern Maryland. There's radium actually in parts of Anne Arundel County and other radionuclides. These are all natural. Saltwater intrusion is natural as well, but it's usually caused by excessive pumping that draws in the bay water, the ocean water. So for a geogenic affected aquifer, I would prefer to call it degraded. Contaminated kind of implies a spill of some sort or a release from the surface. But yeah, it's true. You ask, are we drawing water from degraded aquifers? Yes, in fact, we are, and maybe some of you might live in areas where close to the bay, the Aquifer aquifer actually has elevated saltwater. We're starting to see parts of the Magathy aquifer on the Broadneck. Certain communities are seeing higher chlorides. So it is happening in Anne Arundel County, and perhaps those might be better areas to target injection. That could be one option. So I hope I kind of answered the last part of your question, Sally, was would we create more contaminated aquifers if MAR water was pumped into it? Well, that is the danger, and that is the concern that we have. The types of treatment they have is very sophisticated and technologically advanced. What they're proposing is a carbon-based. It's not a membrane based filtration. And they have a demonstration project where they have been able to reduce these harmful constituents to a very high degree. But that's not to say that some part of the treatment process might fail at some point, and and then we're going to be regretting our decision. But and I'm not an engineer, so I just have to say some of these other questions are a bit out of my league. Let's see. So the next, I'll just continue with the questions if that's all right with you.
Sure.
Okay. So on to Paul's questions. Number one, MAR is promoted as a means of protecting our sources of drinking water from aquifer depletion. However, other jurisdictions use river water or desalination to supply or augment drinking water. Anne Arundel County has several rivers and is near the bay. Why should we use MAR rather than some of these other options to assure a future supply of drinking water? Well, that is an option. So one thing about using surface water is usually the storage capacity of any kind of treated water is usually requires some type of reservoir. And that's quite often what you see in Western Maryland, west of the fall line, where you have crystalline rocks and the geology is more amenable to impounding that fresh water at the surface. In the coastal plain, we're basically living on a pile of sand, right? So if you try to pour water in a sandbox, what happens? It infiltrates, and it's very hard to keep a reservoir in the coastal plain. And I think that's one technical issue with having a surface water reservoir of some sort. If you were to keep it in, water towers or some kind of engineered solution, that would be an enormous engineering project for the amounts of water that they require. And then, of course, desalination requires a lot of energy. It's very expensive, and with such great reserves of fresh water so readily available, it doesn't seem, we're not at that point. We're not at a point like in California or other areas where they really are seriously using desalination. So I hope I
And Andy, how far do you think, or how far off in the future are we thinking about maybe running out of drinking water in some areas in the county?
Well, in the county, we actually, so David Andreessen, he was my former boss, former chief of the unit I'm with now. He constructed a groundwater flow model for Anne Arundel County back in, I think, 2020 or 2019, where they basically wanted him to max out the pumpage that they could ever possibly do. They kind of a maximum build out, and then pump the heck out of it in the simulations until 2086, I believe it was. And this was to kind of, I think part of the reason was to justify exactly this type of project, to show, look, if we really do throw at our maximum levels and pump at our maximum levels, we're going to be running out of water, and we're going to need some solution like MAR to supplement. Well, following all the simulations, there was very little. I mean, we're still above all the regulatory limits. That's not to say that we would want that kind of scenario, but in Maryland coastal plain confined aquifers, the regulatory limit is defined as the 80% management level. It's 80% of the depth from the pre-pumping levels to the top of the aquifer. At that threshold, when 80% of that drawdown, that available drawdown has been reached, that's when MDE will put a stop on any further use of that aquifer. And it's actually happened in certain areas of Charles County. It's happened in 2 different aquifers in Charles County. But it's pretty rare that it does happen. And Anne Arundel County is blessed with much better aquifers than Charles County for geologic reasons. And I don't know if I should even go into that. It's a long story. but I guess you should just know and be happy that your county is relatively blessed with high yielding aquifers that recharge rather quickly. They don't deplete as quickly with use as in other parts of southern Maryland and the coastal plain. But where was I going? Where was I going with this? I have a way of sidetracking myself just by talking. Let me see. So
Paul
you
has
had
a couple of
asked,
additional questions.
yeah. So I'm sorry, I wanted to get to Paul's. I believe you had asked.
Just how far in the future we have to worry about things.
Yeah. So how far? Okay, that's right. Thank you. So with this models and the simulations they ran, there was really no critical areas except for a few areas near the outcrop areas that were starting to reach that 80% management level. So even under the most extreme scenarios, in 2086, things are still relatively well, they're available. Let's say they're not. It's not an ideal situation if we pump that much. But and here's where I'm going to make kind of a suggestion, and maybe this could be a talking point if you ever do talk to the county engineers and those folks. If the water is good enough to pump into a pristine 100,000-year-old aquifer, why isn't it good enough to put into pipes and send to the homes of your customers?
Yeah.
And by doing so, you would pump less groundwater. You'd have less drawdown from your well fields. And that could be a solution. You would require infrastructure. It would require quite a bit of pipelines and such. And I'm no engineer, but that's a question I've never gotten a straight answer from them about. Okay, I guess I'll keep going here. Number two, what is the cost per gallon injecting, retrieving, purifying, and distributing water in the MAR cycle? I'm afraid I really can't answer that question. You might want to talk to Chris Phipps. No, I'm sorry, not Chris Phipps. Chris Phipps is no longer. So Chris Murphy is the engineer
Right.
with Anne Arundel County DPW. Chris Phipps used to be the leader of the DPW, and now he's actually working for the consultant that's working on the MAR project. So he might be another good person to ask, but I don't know the cost. I think it might be. I think when it comes to I have seen some slides from them, and getting back to the TMDL issue, I know that they costed out the price to hook up a lot of the homes that are on septics around the county, which would reduce the TMDL load. And it was an enormous cost. And then they looked at different options, and then MAR was kind of part of this cost benefit analysis where they could actually divert the nutrients into the subsurface. And I think that's where they landed. But it really is an engineering solution to a surface water issue as far as I see it. Okay, how fast does water typically diffuse in Anne Arundel County aquifers? Will our recharge quickly move away? Well, that's a difficult question. Obviously it's not like a bathtub where if you pour water in one end, you're going to see the level rise everywhere. It's an aquifer it's a porous media. It's basically saturated sands with varying amounts of clay and varying amounts of internal confining units. It's actually, when you see, maybe I can show a graphic now if that's okay with you. I mean, this might be a decent chance to show you some of the hydrogeology, I guess. So tell me if you can see my screen.
Yes.
Okay, unfortunately, these controls are blocking. Okay, here we go. Yeah, so here's a here's a cross section through the coastal plain of Maryland, starting at roughly I-95 where the fall line is, going to the Atlantic Ocean on the right side, Chesapeake Bay in the middle. So Anne Arundel County would be kind of this section near the west, where it's labeled Western Shore. And you can see the various aquifers. They're often depicted as just kind of monolithic bodies. So you see the Patuxent Aquifer on the bottom, the lower Patapsco is the next lowest. And I think those are the two that Anne Arundel County are targeting. So when you look at this, you think, okay, there's quite a bit of confinement in between. They're distinct bodies. Everything looks tidy, like a Smith Island layer cake or something, right? But in reality, these, especially the Potomac Group aquifers, were deposited by rivers in the Cretaceous, so the age of the dinosaurs. The basin at the time was above sea, so all of these deposits were laid down by rivers, and so as in a fluvial deltaic system like this, you have an anastomosing channel that kind of sweeps back and forth across a floodplain. And within the channel, you get the sands. That's where you get the aquifer material. That's what holds water the best, are those high water flow deposited sands. On the margins, you get the clays, which settle out in the floodplain, and those kind of become the confining units. So within that bulk of an aquifer that we called, say, the Patuxent, what you're really looking at are a bunch of sand bodies, ribbons of sand, somewhat discontinuous, somewhat connected, mixed in with clays and silts, which really may inhibit the water flow as well. So it's kind of a rat's nest of channels and pathways for the water to flow, if that makes sense. And the effect of that is when you drill a well, here's a diagram where you have well A, well B, well C. These might only be 100 feet apart, 200 feet apart, but you may encounter completely different aquifer sands or bits of the confining unit that actually have sands within. And so I guess this is all to show you that it's rather messier than it's often represented. So oftentimes what you have is vertical migration through a confining unit, however slower than you might have horizontally. And you might also have areas within an aquifer that have quite a bit of clay and inhibit the flow in that direction. There could be preferential flow paths based on the way the channels have been oriented. So the question is good. How fast does water typically diffuse? And it's really not an easy one to answer. It's really the best way to measure it is to monitor it. So if you were to actually put in a tracer of some sort and try to pick it up in a down gradient well, you could measure time of travel. Time of travel is greatly influenced if there's any kind of well that's pumping. You could really draw the water quickly, much more quickly with a discharging well. But in general, when you inject into an aquifer like this, what you're going to see is a mound. So it's going to tend to pile up around the well. It may even go up through the confining unit into an upper aquifer. And it may not disperse sideways for many, many years. And as an example, this is from the Hampton Roads project, the SWIFT project, where they've done quite a bit of groundwater flow modeling. On the left, you see 50 years on with no change in any kind of status quo. There's no injection. There's a lot of withdrawals in the center of these red dots. Those are cones of depression around withdrawal wells. And you can see when you withdraw water, the effect goes out for a certain distance, but then at some point it dissipates. And it's exactly the same on the right. What you see is injection wells at Hampton Roads. There's kind of a well field of 4 of them, it looks like. And there's a mound that's kind of centered around that injection point. So it's really the reverse of a cone of depression. It's a groundwater mound, or a cone upwards, inverted, that's starting to put the plume of injectate into the aquifer. And this is a 50-year relation. So this is the distance. You can kind of see how far out it goes. Unfortunately, there's no scale on this map. Bad cartography. But if you know anything about that area down there, I guess it would be 10 to 20 miles, perhaps. That's a guess. This is all to say that, you might see an effect. You might see an increase in pressure, because we're looking at pressures, or the potentiometric surface of the aquifer. You would see an effect in the distal parts of the aquifer, but you'd really see the most effect right at the injection site. And I hope that helps to answer.
Yeah, that's good. That's helpful. Thank you.
Okay. And the final question from Paul was, for recycling water, why not use an above ground reservoir for storage rather than an underground aquifer? And I think I kind of mentioned the coastal plain reservoirs really aren't. But again, you could consider a reservoir the infrastructure of piping, of any kind of impoundments that might be, they could, a series of water towers or whatever, engineered reservoirs to hold enough capacity to distribute as a direct potable reuse of the treated wastewater. So, and that's another key. So with MAR, it's often said that one benefit is that when you pump treated wastewater into an aquifer, there are subsidiary filtration and dilution benefits by moving through the subsurface. Does that, Mike, I see you kind of...
I know you can see that.
Yeah. So, I mean, this is true in the near subsurface. There are, it's exactly what happens with a septic system, right?
Mm-hmm.
Things break down, there's bacterial activity. Usually that's an anaerobic process. But in a deep confined aquifer, I don't think that's a valid argument. That's my opinion. But that is often one justification for doing indirect potable reuse. That would be first putting it into an aquifer and then withdrawing it at some later time. Now, direct potable reuse would just be putting it in a pipe and sending it to a house. But there's an awful lot of bad publicity when you do that. It's often called toilet to tap, and that doesn't sound good for most people.
Not good marketing, huh?
Not good marketing.
Yeah. Andy, you mentioned that in some cases the injection could rise up to an aquifer above the injection point and introduce the material, the recharge material, to an above, higher up one. Wow.
Yeah.
So if that were, and then you mentioned that there was a contamination issue in Tidewater, and they had to withdraw the. How do you do that?
Yeah, well, they just reverse the pumps. In this case, they have a well that can both inject and withdraw. So they mainly use it for injection, obviously. And once they realized, I guess through periodic testing, that they were above the MCL for nitrate, they realized they had already pumped it many thousands of gallons in. So they reversed it. And I can kind of, if you want, I can send you some materials afterward, but there was a press release that was related to that. But it's something that I think people should be aware of. And I'm not bringing it up as a scare tactic. I think it's a very valid point to make, because it's not often mentioned from the proponent's point of view. But there can be breakthroughs in the treatment chain where it actually makes its way to the source, or to the destination aquifer. And if it's not nitrate, it could be something else. That is one of our primary concerns.
You said something about modeling, and I know that they're working on a model now of the area.
Yeah.
And it does seem like that would be a requirement before you started pumping into an aquifer, so that once it's in there, you know where it goes and how fast. Is the model good enough now to justify doing a MAR, or?
You know what? I really don't think it is. No. So you mentioned that so right now USGS is leading the effort to create a regional coastal plain model for Maryland. So it would encompass all of those layer cake layers throughout the entire coastal plain, eastern shore, parts of Delaware, and parts of the neighboring states. And this would give a good indication of sources of recharge, how it would affect the regional usage and pumpage and supplies and sustainability. Simulations could be made, predictive simulations out into the future. It's really, it should be a requirement. And I think MD is basically indicating that it should be as well. And Anne Arundel County is actually very interested in having this done. They're providing a lot of the funding. So we're helping out with the model by providing our hydrological data sets. So we have the 3D aquifer framework for the entire coastal plain that will be used for the model. We have hydraulic properties for many of the locations in the different aquifers. And there's water use that has to be accounted for, recharge, all the stream networks, everything has to be accounted for in the model. But in the end, it's something that, yeah, as you say, I think it's necessary, and a localized model would have to be kind of constructed for that particular site, a site-specific model. And I think they really need to collect a lot more data from the aquifers, perhaps continuous coring, so that you could get at take a closer look at some of the aquifer materials, look at permeabilities, look at the geochemistry of the sediments and what might become mobilized. So with certain MAR projects, there are concerns that certain geochemical conditions can mobilize metals such as arsenic or manganese, which are natural contaminants, geogenic. And that's something we wouldn't want to happen, obviously. So there's quite a bit that I think needs to be explored before this is ready for prime time.
Hampton Roads had that problem, and they had to try several different chemistries to get a balance. So they didn't get well plugging because of the alteration of the geochemistry of the clays.
Yeah, that's right. That's more of an engineering problem where they
Sure
really clog up the screens.
was.
I guess what I'm talking about is maybe more of a health risk problem that could mobilize contaminants.
Yeah, I understand.
Yeah.
Did you want to say a word or two about the need for monitoring wells for the groundwater modeling effort?
Yeah. If you don't mind, I do want to put in a plug for some of our needs. You guys have been a great advocate for our work, and if I can kind of show you some of the things that um, are necessary for what we do. So we maintain an observation well network that has roughly 470 wells. It covers most of the major aquifers within Maryland. You can see west of the fall line, everything's unconfined water table conditions. So it's really just a single layer that we're monitoring, and mostly it's for climate response, drought monitoring. When you get to the coastal plain, you see quite a bit of the different colors. So that's looking at the different layers. You might have wells in the same location, tapping different aquifers. And we try to keep a good look on levels within all the major water supply aquifers. Now, one big problem is that I think I pulled up the wrong. Let me get the other one here. One big problem is that the well network really doesn't have a steady funding source, and it's aging. So we have wells that go back. Some of them were constructed around 1908, I think, one of them, in Annapolis Waterworks. That's a pretty old one. It's got like a brass screen. It's actually surprisingly in good shape, but we have others that are failing. We've had some that here's an example. We have a well camera that we can send down our wells. This one I was measuring and I heard a rushing water in the well, and I thought, oh, that's not normal. We put the camera down there, and there'd been a rusted hole in the well casing, and there was shallow groundwater running down into the deeper aquifer, which is a really bad situation. So here we have this kind of aging network of wells, some of them actively failing, others that we're losing access to. Sometimes we rely on homeowner wells for once a year measurements just to get a good look at a regional look. Some homeowners change hands, we lose access. So over the years, it's been neglected, and we have been losing wells. And so we're trying to locate a funding source to drill some new wells, to make them more future-proof, put them on state lands, and to have some kind of stable funding source for maintenance and replacement. So that's kind of my little plug.
Can you give us an idea of approximately what the cost of a significantly deep monitoring well, a new one, let's say, to put in, and not the maintenance so much, but just the actual drilling?
Yeah. I've got an estimate here. It's about $100 a foot. That's
Mhm.
everything from drilling, logging, aquifer testing, construction of the
Yeah.
well itself. And this is kind of a mind-boggling look at our assets that are tied up in the well network. Of course, we don't own every single well. A lot of them are owned by utilities that give us access to the well to measure and such. But and certainly not every well is in need of replacement or maintenance. But if we could target like 10 a year or something like that. Certain aquifers are rather deep, as you know. Some can be over 1,000 feet.
Right.
Others are much shallower for just looking at a drought monitoring well, it could be 50 feet deep or something. So it's quite a range. So I hope that kind of helps. It's not a great answer.
But it's several tens of thousands of dollars per well, right?
Yeah, I would say probably on average 30 to 50,000 a well. And for the
Right.
deeper wells, much more.
Mm-hmm.
Does anybody else have questions?
Yeah, I have one question, comment. Andy, I was thinking that from our discussion, that really I think what this whole decision rests on is the risk-benefit ratio. And so the question I think is at what level of demonstration, all right, would minimize the risk? There's the operational risk, of course, there's the detection risk, there's the failure risk. So at some point, I think those are the three critical questions that have to be answered. And I think from our discussion, I think you were saying that if we could run that into an aquifer that's already degraded, all right, to demonstrate the long-term feasibility, that would be the way to go. And you going to comment on that?
Yeah, so I did mention that, and I think as at Hampton Roads, where they are using a degraded aquifer for their operations, it would be much more preferable to, something that's already affected. It's a guinea pig. So do you do you do your experiment on your prize guinea pig, or do you do it on the one that's, that's a horrible analogy. I'm sorry. But I think you know where I'm going with this. It's the risk to the pristine aquifer. When you have other options, I think it becomes less palatable because we can actually show areas where there is saltwater intrusion. For instance, the Aquia Aquifer near perhaps the Mayo Peninsula or Annapolis Neck, or now we're seeing it, the Magathy Aquifer on the Broad Neck. I know there's a wastewater treatment plant on Broad Neck, and I think CH2M Hill did a technical analysis of the different wastewater treatment plants and the different available aquifers that were within injection reach of those facilities. Broadneck was one of the ones that they were looking at, and I think they determined that Upper and Lower Patapsco had capacity. Patuxent at that location is relatively impermeable, and it would probably not be a good candidate. So I think they've done the preliminary analysis. I think they settled on Crofton because there was the most capacity. And
because what?
Well, I think they determined there was the most capacity for injection.
Yeah.
Yeah. And but there could be other reasons. Maybe it's economically attractive for other reasons. I really don't know. But yeah, I would say it'd be more palatable from my point of view if we were trying it in an area that was already degraded.
Do you know if they looked at Edgewater? It used to be a treatment facility over here, and now it's, I guess, just a pumping station. But they still have the land, I believe, Lloyd, don't they?
Yes. No, it would not work at Edgewater at all, because there's no what you need is a source of wastewater being already treated to some high degree, and then you
Oh.
treat it to a further high degree. We don't treat wastewater on the Mayo Peninsula. We simply pump it to Annapolis. So
Right,
if we
and
did it at the Annapolis plant, that might
Right.
be beneficial. Because
Yeah.
there you're going into an aquifer that's clearly compromised by discharge, by saltwater. But you don't probably have the area there to do it. Separate your monitoring wells and so forth. You're right on the bay, there you are, boom.
Hmm.
So that wouldn't work. I think Andy's suggestion about Broadneck, possibly Broadwater, just south of us, that also is on the bay, that might work. There's land in both of those.
Okay. This is the report I was talking about. I don't know if you're familiar with it. But within it, they did do a little, they did a cost, let's see, where is it? They looked at Annapolis, Broadneck, Cox Creek, and Patuxent.
Yes, right.
Patuxent is what they settled on, I think.
Yeah.
Um,
I think it has to do with the volumes involved, the land area that they can operate in, the existing monitoring wells that are there. We did a tour of the plant. They gave us a little bit of information about that. So from an economics point of view, it seems to be their choice, I think, and an engineering point of view. But I
Yeah.
don't think that they're looking at it from exactly the viewpoint you're looking at it.
no, we have different MOs, I guess.
Right.
Anybody else have questions? Not hearing any. Just a couple from me, if you might. If we were to do some advocacy for gearing up the monitoring well system, to whom would that advocacy go?
Oh, the monitoring well. Yeah. So let me bring up one last slide that kind of indicates. Let's see, where is that? So one thing that's always been kind of talked about all the way back to the Woolman Commission. And by the way, this is I know you all are very familiar with the Woolman report and recommendations. These are the recommendations from the report, that wells there should be within the state network, there should be additional wells, and we haven't quite reached those milestones, as well as stream gauges. But within the Woolman report, they also recommended water appropriation permitting fees. And this is something that all of the neighboring states have, except for Maryland. Every state in our region has some form of permit fee that goes toward maintaining the regulatory agency, as well as things like the monitoring well network and their tools that they use to make their assessments. So I would argue that would be something. I know it's not a popular thing, and I know in Maryland, anytime there's a new fee, it gets some bad label like the flush fee or the rain tax or something. But water, it's relatively abundant, and extremely cheap, and maybe there needs to be more of a value placed on it that the larger appropriators should be required to pay, and then that money could go back and fund the necessary research and monitoring to ensure that the resource stays safe into the future. That would be my plea, and that's how I would frame it.
Well, funding sources are one thing, but somebody's going to either embrace the idea of this or they're not. And then second question, or later questions is funding sources. Is this the Secretary of DNR who calls? Where are the stop points toward getting this in a budget?
Yeah, well, I guess this would fall under MDE. They do the permitting. They
Okay.
do the groundwater appropriation permitting.
Right.
And so this is from a presentation of Saeed Khazrai. You may know him. He was the previous
Yeah, we do.
supply program. And I think he's presented to your group quite a few times. He's retired now. But it's something that's been kind of it turns out a pipe dream for many years, but it's appeared in official documents like the Woman Report, and I think it would go a long way. The groundwater flow model that came out of the Woman recommendations as well, and until it took something like the MAR project to actually create a situation where funding was available to make it happen. So, I mean, I don't want to whine. I know everybody's needing more money, but when it comes to water resources, you'd think something like the big drought around 2000 and the recommendations, which were, it's kind of a scary time. I think everybody was concerned, and there was a lot of smart people and good thinking that went behind the recommendations, but they really didn't come to fruition. This is kind of our guiding documents still to this day.
When you talk about large appropriators paying more fees, you're referring to some of the large appropriations for the farms on the Eastern Shore, for example.
Well, agriculture gets a pass quite often.
Yeah, they do.
And maybe for good reasons. I mean, farmers aren't necessarily the richest of people, and they really do require water for their operations. So there may be good reasons, but I don't think that's going to fly. Not in Maryland.
So what appropriators are you talking about?
Probably the large municipal.
Yeah. Like the city and county, for example, who draw water from these deep aquifers. Yeah.
Yeah, and of course that's not what you want to hear, because your water bills will be going up as well,
Sure.
right?
Well, look what's happening in Baltimore County just now. Humongous increases in water bills because of their cost to maintain a failing system.
Yeah, the infrastructure is so ancient there.
Yeah, and it's been neglected all these years. I think our system's probably in better shape, but still we use a hell of a lot of water.
Yeah. And maybe MAR has a role to play, but maybe just direct potable reuse rather.
Mhm.
Andy, there's one more, and I think we're going to try and wrap this. The harkening back to how you began this, it really sounded like the driver here was an economic driver, the avoided cost of discharge fees. So, setting aside saltwater intrusion and the other threats to the water supply, has anybody laid out the costs of what would be the avoided costs on the discharge side versus the creation of a system to do recharge? And a second layer of concerns would be, if there's a screw up, what are the costs associated with that? But just on the top line, I mean, is the recharge some multiple cheaper than these fees?
That's a good question. I'm trying to find a slide I saw. This was in a presentation that Anne Arundel gave. Can you see these slides whipping by?
Right.
There was a cost comparison of the options, and I hope I can find it, because I hope I'm not wasting your time. But essentially, it showed the cost of dealing with the septic system to resolve the TMDL issue, that being the highest, connecting to sewer all the septics, that would be the highest option. highest cost option. Then there were other options that slightly less, where they had more okay. Can you see this?
Yeah,
So this is the range of capital costs. Based on this, they determined managed aquifer recharge was somewhere toward the bottom.
right.
Septic connections being higher, stormwater infrastructure retrofits being the highest, apparently. But in terms of the costs for the risk of, injecting untreated water into an aquifer, I don't know. I think that's kind of, how do you put a price on that? It's
Well, some estimate I think is definitely worth knowing. On the top line, here's the ones. Just one other comment about extending the lines and taking out all the septic systems. One of the concerns that on the other side of the house, the growth action side, is trying. All these things tend to trigger a whole lot of subsequent development because usually the constraint is sewer capacity, and once you take that away, there's even a bias to get more users on the line to reduce individual costs, and that comes with schools and roads and cops, and so this, you can't just draw a wall at the utility side of it. There's a whole lot more involved. So.
yeah.
Well, unless somebody else has a question, and I'm not seeing it, last call.
Yeah,
Okay.
just a quick comment. We have recorded this and that probably will suffice. But if there's anything that you would like to forward to us, either a link to a report or some other slides you were using to demonstrate the need for these monitoring wells, any of that kind of thing you'd like SEPA to see, if you could get them to us, we'd appreciate it. We'll include them in our distribution, and we'll be cautious about anything that you're and not pin you down on MAR, because I think we learned what the position of your agency is.
Yeah, and I guess I should say, while we're still being recorded, that while I believe that I represented our position in what I told you today, I think some of what I said is more personal as
I
well.
understand.
Yeah,
Right.
so I don't want to speak entirely for DNR in what I've told you, but from my experience, from my knowledge, from my sense of the resource, I think I've given you the best information I could.
Yeah. And we
And
want
I'd
to
be
thank
happy.
you for
I'd be happy
being
to
very
share.
frank about it and answering our questions thoroughly. Thank you very much.
Yeah.
Yeah, no problem. I'm happy to do it. And if you have any follow-up questions, please let me know. And I'll forward any links I have that could be helpful to you.
Very
All
good.
right. Thank you.
All right.